Welcome to EducAgent Studio, where a crew of AI agents help us teach and you learn with ease. Here's the problem we'll solve today. We're given the rational function f of x equals the quantity x plus 4 over x squared minus 9, and we want its domain. Every real number you're allowed to plug in so the function actually makes sense. For rational functions, the only problem happens when the denominator becomes 0, because division by 0 is not allowed. So we focus our attention on the denominator, x squared minus 9. To find the forbidden inputs, we set the denominator equal to 0 and solve. Any solution we get here must be excluded from the domain. This is a difference of squares. X squared minus 9 factors neatly into the quantity x minus 3 times the quantity x plus 3. Think of it as x squared minus 3 squared, which always becomes the quantity x minus 3 times the quantity x plus 3. A product equals 0 only if at least one factor is 0. The first factor gives x equals 3. The second factor gives x equals negative 3. So the function is defined everywhere on the real number line except at x equals negative 3 and x equals 3. Those 2 points are holes in the domain because they make the denominator 0. In interval notation, the domain is all real numbers split around the excluded values negative 3 and 3. And in set builder notation, all real x except x not equal to negative 3 and x not equal to 3. The big takeaway: rational functions are defined everywhere except where their denominator becomes 0.
X squared minus 9 hits 0 at x equals plus or minus 3, so those are the only exclusions.
Final answer: all real numbers except negative 3 and 3. Keep going. Watch the next video to see another cool twist on functions and how small algebra steps can reveal big behavior changes.